Hi, I'm Grandmaster C. You've seen me in such fine quality, epic chemistry educational videos such as how to use an electronic balance and the water density lab. Okay, this video we're going to focus on how do we make accurate measurements with a graduated cylinder. Now, a graduated cylinder looks like this, and you may notice that there are a bunch of lines on there. We say it's graduated not because it went to school, but there's a scale that we can measure our unknown amount to a standard that we know. That's the whole point about measurement. But how do we go and measure this? Well, we have to understand how is it that liquids behave when they are in a container. So behind me here, I have a magnification of a cylinder. And when you look here, when you look at water, water does not go nice and flat. Okay? That might work on a Disney movie or something like that, but it does not do that in the real world. So what happens is it forms this. Well, why is it forming this? Well, what's happening is that you have a little bit of water that clings to the sides of the container that it's in. So what you have here is a shadow. Okay? So you have a shadow effect there. So then the question comes down to is, okay, you got the shadow effect here. How do we know where to measure this? You're going to look at the bottom, the very bottom of that curve. This, ladies and gentlemen, we call that the meniscus. Okay? It's the meniscus. Now, some people would say, oh, wait, I thought that's in the knee, because like my friend tore his meniscus playing basketball. Right, you got that. But here in chemistry, we're looking at the meniscus of liquids. Okay? And in this case here, how we accurately measure using these, it's the meniscus. That's how we use this. So you're going to read the bottom. So in this case here, this is 20 milliliters. This will be 19, 18, 17. So that's a 17 milliliter reading. Okay? The rest of it's filled with water. That's where it came up with. That's the 17 milliliters. All right? Now, how's that going to work in the real world? Okay, so you have a cylinder like this, and let's say you need to fill up to, let's say 8 milliliters. Now, I got about 7 milliliters in here, but I don't know if you can see it, but there's like a few air bubbles in here, especially right here, okay? Air bubbles are bad, because if you have air bubbles, it means that your measurement isn't going to be accurate. In fact, if you got air bubbles in there, then that means the volume you're reading now is going to be actually less in the real world because those air bubbles are there. If you're thinking about going into nursing, for example, you don't inject the patient with a syringe that has an air bubble in it because the air bubble travels through the bloodstream into the heart and can cause a myocardial infarction, what the rest of the people call a heart attack. I'm very serious when I say this. So how do we go and deal with the issue of air bubbles? Well, one way you could go and turn the thing like this, okay? Of course, you could like tap it on the table. That's another way you can do that. So before you go and annoy your teacher with, is this the correct volume? Make sure you don't have any air bubbles in this, okay? Now, what happens, I'm at 7 milliliters, how in the world am I gonna get it to 8? Glad you asked. Because I happen to have a dropper here with water, and what you're gonna do is slowly add it in. Okay, so you're gonna add it slowly and surely until the bottom of the meniscus reaches 8 milliliters. Now, you may notice I got a few air bubbles in here, so that's not accurate. I'm going to see if I can get rid of them. And, okay, I got one big air bubble, a couple of air bubbles. Oh, okay, I think I got it. No. Missing a couple. Okay. I think we're good. And am I at 8 milliliters? Almost. Okay? Well, what happens if I overshoot? What happens if I get at 9 milliliters or 10 milliliters and I really wanted 8 milliliters? Okay, that's when you're going to have to pour out a little bit, or another idea would be maybe you can tilt it depending how deep. Well, this is not going to work very well, but you could do this and maybe soak up a little bit. Okay? And you could try that. Although it would be a little bit harder for you guys. It's easier to pour it out for something like this because this is tall and slender. Some of the cylinders are shorter and you could get away with it. I would recommend just gently pouring it out. Okay? Alright guys, that's it for how to deal with the meniscus and how to read that. Like I said, it's a crash course for you guys. This is Grandmaster C signing off.